So thank you all for joining us. We know you have busy schedules, so our goal is to provide great information to you to help you in your role. We are Nabto, and I'm Tariq Hassan, the business development lead here in the United States for Nabto. And we have with us here Jim, head of our sales and partnerships out of Denmark for the entire company, as well as Ulrich, our CTO from Denmark, who will be presenting the webinar today. Very nice to see everybody here. Please think up some questions that you'd like to ask for the end, so that we can maximize the opportunity here for everybody to learn as much as possible and get all your questions answered as well. So the webinar today is about IoT and WebRTC and the video surveillance cameras use case. So I'll just kick it off. I'll just hand it off to you, Ulrich, if you're ready.
All right. So let's start with try to get the PowerPoint gymnastics going. So first, let me just say a little bit who I am and what Nabto is about. Yes, my name is Ulrich. I'm the CTO at Nabto. We do a communication platform for the Internet of Things that allows client applications to interact directly with IoT devices. We have worked quite some with WebRTC scenarios and worked with the vendors implementing WebRTC in their devices, and we've seen some of the challenges that they often encounter. So I want to share some of those challenges today and also present some solutions to the problems and how you can work around that. So feel free, it's just a small audience. I think it's fine if you have some questions, just say something, that's fine. Otherwise we can save it for the Q&A session afterwards. So let me just see if this works. Can you see PowerPoint right now?
Yes.
Great. So the agenda for this presentation is brief, so we will have a lot of time to discuss afterwards. First, I'll introduce WebRTC in general, as you probably know from normal teleconference video meeting scenarios where you have humans interacting with humans. And then I will describe how you can use the same technology in video surveillance scenarios and why we think that's a good idea, some of the challenges and some of the solutions. So let me just see here. So WebRTC has been around for quite a while. It's been used for more than a decade in browser-based live streaming. You probably already know it yourself. You've probably tried it, at least in Google Meet, and if you use Slack or Discord for voice and video calls. So the typical use case for WebRTC in those scenarios is a video call between a number of people. And it's standards based, so it works in all browsers, no hassle. You don't have to install anything. It's just there and it works. Performance is great, very low latency, adaptive bitrate, everything's nice, and it's secure. At least potentially, it's secure. WebRTC gives you the handles to build a secure solution, but you can still build an insecure solution on top of that. But at least the standard makes it possible to build a secure solution without too much hassle. So that's how a WebRTC-based video call normally looks. You have the two peers participating in the call, sitting on two distinct networks. They want to establish some kind of connection, a video connection, where you can send the video streams. So WebRTC standardizes this this path called media plane, where you actually send the media data. All the details about how to establish a secure direct connection is handled by WebRTC, and also the actual streaming implementation. So that's the media layer. How you exchange the information necessary to establish this connection is not specified in the standard. You have to deal with that yourself at the application level. So that's what denote the signal in plane. So basically, you need to exchange some piece of information to allow WebRTC to establish the direct connection. So how do you establish this connection between peers? Normally in a video teleconference scenario, you have a shared URL with a link that you click. And this allows the participants to exchange what's necessary to establish the WebRTC connection. That's called SDP, offers and answers, and nice candidates, and details like that. So it's enough information to establish the direct connection. Also, we have public key fingerprints exchanged on through the signaling that's later used to establish a secure media connection. So you need to trust the signaling path here, because you're not supposed to be able to inject fingerprints or manipulate the fingerprints. So the signaling plane allows you to exchange the SDP messages, and the media plane is where WebRTC establishes the local peer-to-peer or a relay connection. Relay, that's through a turn server. If it's not possible to make a direct connection, you use some indirection through a relay. So WebRTC also makes sure to make the implementation. It manages the DTLS handshake to make sure you have a secure path, end-to-end encrypted, with the public keys used in the DTLS handshake. They are validated using the fingerprints from the signaling phase. So basically, after you have set up the media path, you can start the media stream, and that means that the users typically see a very low latency video feed, a few hundred milliseconds in good network conditions. WebRTC mitigates the packet loss, so you don't have this cumulative latency that you often see if you use some TCP-based streaming protocol. So that not so much in this scenario, but when later comes to the camera scenario, that's a typical artifact of a TCP-based streaming that you have more and more lag. So horrible user experience. So stream is end-to-end encrypted, and everything is taken care of by standard software. So that's lovely, and we like that also in the video surveillance, because you've just seen this is standard space. We have a lot of clever people, big companies spending a lot of effort to make this standard. So let's see if we can leverage that for our cameras. We have many requirements in common between the cameras and a video call. With a camera, you want to see real-time performance. It's very important. I want to see what's happening right now, not 10 seconds ago, and definitely not a few minutes ago. And I want this to be secure. I only want people that are authorized to view my video feed, and I must be certain that the video feed actually sees from my camera and not some impersonation or a fake camera. And then, of course, it should just work. I don't want to install browser plugins or deal with all the hassle of the 1990s. So the traditional approach, non-WebRTC based approach, is often plagued by poor performance, the lag we talked about, poor security, or some proprietary streaming implementations. So it would be good if we could somehow use WebRTC in the video camera scenarios. But it's a little bit different when you have a surveillance camera and instead of a conversation. So in a video call, you have two humans, you have a rendezvous point, you have a place to meet, for example, the Google Meet link. You have a way to mutually authenticate through this secret that can be shared in the link. And of course, you can also recognize by just looking at the other peer that this is the person you expect. I know nowadays you can't necessarily count on that, but at least often it's a good hint that you're talking to the right person. So as you can tell, it's not that simple when the other peer is a camera and not a person. So first off, the other peer is not actively wanting to establish a connection with you when you want to look at the video feed. So it must be somehow passively listening for incoming connections. It also poses several new challenges. You don't have a rendezvous point like the meeting URL. And how does the camera ensure that users are who they claim they are? Oh, okay. So we have the authentication. Who are the users who they say they are, and are these users the one I want into my camera? And also the other way around. How does the user know that it's communicating with the right camera and not some impersonating camera or other device? So these are the challenges that we face. So basically, we need to rethink signaling. So we want to take all the the features from the standard space media plane from WebRTC, and then rethink the application level implementation at the signaling plane. So the first challenge is that the camera somehow must be registered centrally and stay ready to be connected to from a client. So I denote that passive signaling. So you see here, enjoy the creativity here, where I put a camera on the nice O'Reilly picture. We can see that the camera is communicating with the signaling server, so it maintains a connection there. For example, a WebSocket connection. But it can basically be anything that allows the web server to send a request into the camera. So WebSocket, where you keep it open, you can use MQTT, you can use HTTP long polling, or you can use Nabto-IoT. So I'll tell a little bit about that later on, but these are all options you can do you can use in this scenario. So when a client sends an offer and basically requests a connection to a camera, the camera wakes up and receives this on the connection, and then the active signaling phase can start, the one that we also saw in the browser scenario. No. So sorry. So the next challenge is that we need to do the initial pairing. So assume all cameras have some identity, some a GUID or some other ID in some namespace. And this camera is somehow authenticated through the signaling server. So the users now unbox this camera and wants to connect to it. So one typical way of doing this is to embed the camera ID and some pairing secret in a QR code. So the user can scan this QR code, and then we can use PEG for mutual verification of the pairing secret. PEG is an ingenious cryptographic approach that allows you to verify that two peers knows a common secret without disclosing the secret to the other. So we can use that here. So for example, the different ways of doing it, you can either use PEG at the signaling level, or you can establish an unauthenticated media path connection, and then do the PEG verification on top of that. And that's what I'll show here. So first you do all the signaling with the exchange of the SDPs and the ICE candidates. You establish the media path, and then you open a data channel on WebRTC. So right now there's no trust between the two parties. You just have a data channel and unauthenticated peers. Now you can start the PEG exchange on top of this data channel. Once it's done and successful, each party knows that the other party knows the shared secret. So that's good. So now the browser can, for example, send the OAuth subject from JWT to the camera, so it's ready for subsequent connect attempts. Yes, this is all good. Yes, we have the subject written in some user database on the device, so now it's possible to connect just using JWT, and we can in the future establish secure connections to the camera. But that's a very simplified view on the key use case. And all of this is possible with the open source components. Everything is implementable using the components like these. There are many different alternatives for each. So it's just a matter of building your application. The challenge is, of course, to handling all these different components, making a solid, robust, scalable solution. And that's why I will just mention an alternative solution to building such a custom solution based on these open source components. For example, you can look at Nabto's WebRTC's SaaS solution that has been tailored for video cameras. So it has been designed from scratch to support surveillance cameras and not with the browser-based video conferencing application as the first use case. So basically, oh, okay. So the WebRTC Nabto SaaS solution is based on the Nabto Edge platform. So that means it adds end-to-end encrypted signaling if you use native apps. And also it's a fully SaaS-based solution where you don't have to worry about anything, or you can You can just you can use a hybrid where you use Nabto SaaS for signaling, and then you host your own turn servers. We also provide several open source SDKs to make it possible to implement your application with very little code.
Hi, Ulrich.
Yeah, sorry.
I don't mean to interrupt you. I just wanted to make sure we touch on the question from
Yes.
SK Rack.
Oh, sorry, I didn't see that there was a question. Sorry.
Yeah, no problem, no problem. Do you see? So I can read it to you here.
Yeah.
Do you have any idea with WHEP protocol, if the server is using WHEP protocol for streaming the video, how can we fetch the video? I can fetch IoT publishing message streaming via MQTT protocol. I have difficulty to fetch video from client since video is streaming using WHEP protocol.
WHEP. I'm not familiar with that protocol. I'm sorry. So is it some specific codec usable with WebRTC? I've never heard about that. Pardon my ignorance. Maybe it's a synonym for H26 something. If any of the other participants know about it, feel free to pitch in. Otherwise, you can write an email to me afterwards. I'll be happy to do a little bit of research. Okay.
I guess we can go on till we find out what SKRAC means by WHEP.
WHEP. Oh, it's not something that rings a bell to me. Sorry.
Okay.
Yeah, but if I Google it, maybe I'll see a synonym and then I'll say, it's just that. Okay. So this is an example. Sorry, a code snippet that shows how you can implement the full pairing scenario using our SDKs. You can see how you can do the page-based password authentication. And then so first you open a connection, you do the password authentication, and then you write the OAuth subject from your JWT. So that's as simple as that. That's very close to actual production code. Of course, you need to add some error handling, but it greatly simplifies the procedure. So you can go ahead and try it. Everything is free to use for non-commercial projects, and it's also free for R&D projects. You just sign up at our website. For commercial projects, we charge a small yearly fee for IoT devices for unlimited signaling, unlimited peer-to-peer streaming. Then you can purchase a relay allowance for turn if you want us to do that, or you can actually self-host the turn servers.
Hey, Ulrich. Yeah, so
Yes.
maybe we could just pause on this slide because it's really helpful. But basically, Jim was adding the WebRTC -HTTP egress protocol is referring to WHEP. So WHEP and IETF protocol developed to let us use WebRTC to egress content to other destinations.
Okay, so it's more for sort of like a broadcast scenario where you have centralized dispatch to several clients, or no, it's not something that we are familiar with. We only do peer-to-peer streaming.
I think Shri is saying he'll message you via email.
Okay, that's good. That's good. Just write to ug@nabto.com. All right. Do you have any other questions? Hopefully something that is close to something I know a little bit about.
So I just so obviously so these links here are obviously great resources, right? For a place to start.
Yes.
For anyone that wants to get into WebRTC for video surveillance cameras, correct?
Yeah. So our website is specific on how you can use our platform for signaling. then you can use the links I put on the earlier slide for inspiration if you want to explore how you can implement your own solution based on WebSockets. Then you're on your own, but we are happy to help build a solution if you look at the signaling platform that we provide.
Okay. And this looks like based on research, it seems like WebRTC is growing in this field, doesn't it? For IoT.
Yes, absolutely. And also you can see that it's starting to be used for non-video scenarios where you can use it for use the data channel for direct invocation of IoT devices from web browsers. So it's quite a novel approach to interaction with the IoT devices.
Okay. I was just thinking, we've had these types of questions before, because we're always limited on time in webinars. Maybe if could anyone just reach out to you by email maybe and have a call with you to see how how their particular use case applies, and maybe there's an opportunity to help them, to guide them, that sort of thing.
Me or a colleague, that's absolutely fine.
Okay.
Yeah, and we do have a chat function on the website as well, so they can get in directly touch with one of the team members that'll take care of answering any questions related to this.
Okay. Yeah, I think the key is, with IoT generally, and especially with video surveillance, is how do we reduce the latency, right? And so these are good options now. Increase speed and security, right? And so this is obviously the newest way that we're looking at, right? Is that right?
Yeah, it has been around for a while, but it's so far other approaches to video streaming has been more abundant in cameras, but you see more and more, and it's required or expected by users that it's available.
Yeah, I know the customer is the one who's really pushing for faster speeds, right? Especially with cameras, because it's a lot about their security, for what they're trying to see in real time versus having it being delayed.
Yes, absolutely. People need the low latency for the video streams. I mean, in some of the solutions you can try today, commercial solutions, don't want to mention anything here, but some very big commercial solutions, you have to live with 6, 7, 8 seconds of latency live feed, and that most vendors and users thinks that's not really acceptable. Especially since you can see if you have a video call like this, latency does not have to be anywhere near that.
True. Does anybody have any questions for Ulrich?
Well, I could throw one in.
Sure.
You were so kind to show some of the elements that you could use if you wanted to do your own WebRTC solution, but how about time frame for such a project?
Well, that depends on your level of ambition. It's of course a complex matter to develop such a solution, especially if it needs to be scalable and secure. We have spent a few hours building the Nabto platform, I can tell you. Yes. Good. Oh, it's Q&A session, but that's where we are now. Sorry. Good.
Yeah, I think this is great. We'll keep it open just for a second if somebody has any questions, but I think what we'll do is everybody, we'll make sure we'll send the link of this webinar so everybody can look back on it if they'd like and get some answers to any questions that might pop up later on. And then we really want to emphasize the opportunity to really reach out to Ulrich here. He's our CTO. He has a lot of knowledge, and Nabto's been helping a lot of companies globally in many different IoT use cases. And so if you guys have any questions, this is obviously for free to get some guidance. please feel free to email Ulrich, and he and his team will definitely help answer any questions.
Yes. Good.
Okay, so I think with that, if nobody has any more questions, we can probably wrap it up, and we'll make sure to send the link to this webinar probably this week afterwards. And if you guys have any questions in the meantime, please feel free to reach out to myself or Ulrich or Jim at any time. And we definitely look forward to supporting you on your IoT journey. Okay.
Absolutely.
Thank you all for your time, and have a good rest of your day.
Thank you.
Enjoy.
Thank you, everybody.
Bye-bye.